start copying the guru prediction behavior. So you can see that the teacher predicts things in a with a certain level of confidence. So the student needs to get that confidence just right. When we are doing all this knowledge transfer, there is some math involved. So we are just using something called loss function to balance things out. So we want the student to be just as smart as the teacher, but in a compact way. So for the practical stuff here, so we are installing packages enabling telemetry and setting logs. So it's like preparing our toolkit for our projects, and we are fine tuning the model and making sure it's ready for action. So it's like getting our gear ready before heading out for an adventure. Assalamu alaikum, everyone. I'm back with the third and final part of memory management series in LLMs, which is model distillation. So we are going to talk about the model distillation part, which is also a model compression technique. And without any further ado, let's just get into it. So I basically think of it like a teacher passing on their wisdom to a student, but in the realm of AI. So we will uncover how we can take the brilliance of a big complex model and compress it into a smaller and smarter one. So let's roll up our sleeves and get into the main thing. So why do we need knowledge distillation? So picture this, we have got this super smart teacher model, but it's a bit too hefty for certain situations. So that's where knowledge distillation comes in, and we can shrink that model, like teacher model, down into a leaner, meaner student models. And guess what, these student models are perfect for devices that are not the most powerful, like our trusty smartphones. Plus they are lightning fast, which is a great game changer for real time application like chatting with bots or offering customer service. And did I mention they can also learn tricks from one domain and use them in another? So that's how some AI magic works here. Talking about teacher student optimize model optimization. So let's talk about the nuts and bolts of this process. Model come in all shapes and sizes, right? So the bigger the model, the more parameter it has, and we have discussed it earlier. That's what make it bulkier. But here's the deal: many of those parameters are kind of like extras, taking up space. So we are all about efficiency, so we are gonna cut all those extras. So that's where model distillation comes in. It's like giving our student models the cliff notes version of the teacher knowledge, smaller, faster, and just as smart. Talking about prediction layer distillation. So imagine this: the teacher model is like the wise guru, and the student model wants to be just like them. So it's like start copying the guru prediction behavior. So you can see that the teacher predicts things in a with a certain level of confidence. So the student needs to get that confidence just right. So which is where temperature comes in. Think of it as making the student prediction softer or harder, depending on what the teacher does. So we are finding the perfect balance between mimicking and learning. Then we have immediate layer distillation. Now let's take it up a notch. So we are not just mimicking the teacher prediction. Here we are basically diving into the teacher thoughts at a deeper level. So we are talking about attention and embedding layers. So these layers help the student understand the teacher way of thinking. So it's like learning the secret sauce behind the teacher's answers. And trust me, this part of it is a game changer when it comes to accuracy and speed. The model learns to mimic and basically translate and copy the thinking of teacher model very well. Then we have a model comparison. So picture this thing: that two model, one big and one small. The small one might seem like the underdog, but it's got more like it's got some tricks up to its sleeve. So we are comparing the sizes and performance of these models. Turn out even the small guy can pack up a punch. It's like having a mini superhero that's faster and just as powerful. So the distilled model is like a Swiss Army knife, ready to tackle various tasks with its own style. Then we have loss function optimization. So when we are doing all this knowledge transfer, there is some math involved. So we are just using something called loss function to balance things out. So we want the student to be just as smart as the teacher, but in a compact way. So think of it as a seesaw, where you are basically adjusting the weight on each side to make sure everything is in the balance. And to prevent overfitting, we are adding some fancy terms to the equation. It's like adding a sprinkle of seasoning to a dish to make it extra flavorful. Now talking about model setup, now it's time to set the stage for it. So we have got our teacher model all wise and knowledgeable. Then we bring in the student model ready to learn. So the teacher shares its prediction and wisdom, guiding the student. So it's like a mentor showing the ropes to a rookie. So it's making sure the student gets all the good stuff from the teacher without any extra fluff, because obviously we want to take care of the efficiency here. Now talking about with an example, imagine we have got questions and a hypothesis, and we need to know which hypotheses are correct. So the teacher model basically helps label these hypotheses using some fancy rationale. So then we basically set up the student model with its own architecture and rules. So it's like taking the teacher advice and using it to solve a puzzle. Uh, so let's just understand it with the implementation. Now, for the practical stuff here, so we are installing packages enabling telemetry and setting logs. So it's like preparing our toolkit for our projects, and we are fine-tuning the model and making sure it's ready for action. So it's like getting our gear ready before heading out for an adventure. Uh, After this, of course, there are a lot of challenges here as well, because you can basically follow these steps in the article, because there is a very big implementation of model distillation process, and the implementation also revolve around depend on your specific task as well, because the model you choose for model knowledge distillation and the parameters that you want to basically neglect or keep, the implementation basically revolves around that, and the basic implementation is available in our article section, so you can check that out too. So through this way, you can basically use any model, not any, but uh, the model that can be knowledge distilled. So you can use it in your implementation and use it on your resource constrained devices as well. And of course, nothing smooth sailing all the time. So there are challenges along the way. Crafting the perfect loss function that balances everything can be a puzzle, and picking the right setting like temperature and weights can make a big difference. So we are all also making sure that biases and inaccuracies don't sneak in, and it's like taming a wild beast to make sure it behaves very nicely. Now, concluding everything, knowledge distillation is like a magical process where big models share their wisdom with smaller models. So these distilled models are like pocket-sized geniuses ready to tackle any challenge. So they are fast, efficient, and full potential, but it's not all rainbows and unicorns. So we got to watch out for biases too. So let's have a round of applause to knowledge distillation for making AI even more awesome. And we will discuss about the latency of the model in the next lecture, and also the cost in LLMs as well. Both are very important topics, and which basically connects to this knowledge distillation stuff as well, because most of the things that we are using in model compression side basically sometimes slows down the model performance as well. So latency is a big key here, but we have some solutions for it too.